Energy. In this video, we are going to learn about energy. What is energy? What are the different types of energy? How we can derive the formula for energy, and let's solve different numerical problems related with this energy. Okay, without wasting time, we can move on to the next slide. That is energy. What is energy? How you can define energy? Energy is the ability to do work. So from this definition itself, you can understand that energy is very much related to work. If you want to do some work that needs energy, energy is expended, isn't it? Energy expenditure will be the in order to do a work. We have to utilize energy to do our work. Work is what? Work is force into displacement. So these two quantities, work and energy, are related, and they are that much related that we are using the same SI unit, that is joule is the SI unit of energy also. That is energy, how much if we want to do some work we need energy, isn't it? So both are same only, so we are using the same what we call the SI unit, that is joule, for both work and energy. When you talk about energy, you might have studied about different kinds of energy in your previous chapters and all, like sound energy, light energy, solar energy, chemical energy, isn't it? A lot of different types of energies you are familiar with. Now we are going to learn about mechanical energy. It is the energy possessed by a body due to its position or motion. So there are two different kinds of mechanical energy, or mechanical energy can be classified into two different sections: potential energy and kinetic energy. Okay, so we are going to learn what is potential energy and what is kinetic energy. Kinetic energy is the energy possessed by a body by virtue of its motion. This energy, what we call the kinetic, the word itself is tell you that it is something related with motion. Kinetic means motion, something related with motion. So by virtue of its motion, because of its motion, it is due to the motion we are getting that energy. Okay, energy produced due to motion of an object, that is known as kinetic energy. Example, a speeding train, flowing water, etc. So all these moving bodies, whenever a body moves, it possesses a kind of energy. That energy is known as kinetic energy, and you can write innumerable number of exams because you can make examples by using anything which is moving. Next one, potential energy. Potential energy is the energy possessed by a body by virtue of its position. Due to its position, because of its position, what kind of energy a body possesses, that is known as potential energy. So here I have written the formula of both the energy, that is kinetic energy is equal to half mv square and potential energy is equal to mgh. Now we are going to derive half mv square and mgh. Both are very important. Kinetic energy, first we will be deriving the equation half mv square. Okay, let's start the derivation. So in order to derive this, we need to consider all these facts. Consider an object of mass moving with a uniform velocity u. So these two things are important. We are considering an object of mass m, that is the first criteria, and second, uniform velocity u, that is the initial velocity, that is the beginning velocity. An object is moving with a velocity u, and what is the mass of the object? M. Okay, next, let it now be displaced through a distance s when a constant force F acts on it in the direction of its displacement. So what is the second criteria? Somebody is applying a force of F on that body and that object has moved through a distance s. So mass equal to m, initial velocity is equal to u. Now we are applying a constant force F and the body has moved a distance of s in the direction of application of force. Okay, now it was moving with u. Now we are applying a force. Now the object is moving with another velocity. That new velocity, that is known as v. So the velocity changed from u to v. Before it was moving with initial velocity u. Then after applying a force on it, what happened? Its speed or its velocity changed. It has become v. Now, in order to apply, or when we apply certain force on a body, work is done on the object, isn't it? Work is done on the object to change its velocity from u to v, and that work is done by the force only. Okay, work is done by the force only. So W is equal to F into S, where S is the displacement or the distance moved. Now, the fourth one, let A be the acceleration produced. So that is also important. Now we are talking about when there is a velocity change. When there is change in velocity, obviously acceleration will be there. These all things are some basic things that we have already discussed in the motion chapter. That is, whenever change in velocity occurs, acceleration will be developing. So let A be the acceleration produced. So I hope you understand all these four points. Now we move on to the next slide. Now, according to this equation of motion, v square minus u square is equal to 2s. Why we are taking this equation? See children, this equation contains all the necessary things that we have discussed now. What all things we discussed? We talked about u, initial velocity. We talked about v, final velocity. We talked about a, acceleration, and the displacement or the distance traveled, s. All these factors are coming in this equation. So we are taking this equation of motion, v square minus u square is equal to 2s. From this equation we can derive the value of s. So we are keeping only s in this side and taking away 2a to this side. So what happens? S is equal to v square minus u square divided by 2a. This into 2a will become divided by. Okay, S is equal to v square minus u square divided by 2a. Now, so we are applying a force F, and we know that F is equal to ma. Now we are going to apply this, what we call the value of S in this formula work. Work is equal to force into displacement. Force is equal to ma. Ma into S is the displacement, that we can write this value, v square minus u square divided by 2a. So what happens is that ma into v square minus u square divided by 2a. Okay, so a and a common factors we can remove. Then what remaining next is half. Half is remaining there, this 1 by 2, half m into v square minus u square, half m into v square minus u square. So the equation has become like this, half into m into v square minus u square. Now, if the object is starting from its stationary position, that is, if the object was at rest, when it began its journey, the object was at rest, then u will become 0. If u is equal to 0, the equation will be becoming like this. That is, equation will be changing into this form. That is, kinetic energy E is equal to half mv square, because u is equal to 0. In this equation, if we are considering u as 0, then this value will become, equation will become kinetic energy is equal to half mv square. Okay, so this is the derivation for kinetic energy. I hope you understood. Do it on your notebook. Okay, several times you will have to practice. This is very important. Then next one is derivation of potential energy. This is very simple. No derivation is required. Only we are substituting the values in the equation only. Okay, so a body is raised to a certain height h. This height can be taken as h. Yes, it is written here h. This is the h height, and the body of mass m. M is the mass of the object, and it has raised to a certain height h from the ground. So a force is required to do this. Obviously, force is required in order to raise an object of mass m. We need to apply force. If we are not applying force on object, we are not able to raise it up. So we need to apply certain force F on it, isn't it? F. And the minimum force required to raise the object is equal to the weight of the object, that is equal to mg. Here why we are considering g? Because we are doing it against the force of gravity. So whenever we do this, an acceleration is produced in the body that is equal to acceleration due to gravity. So in this consideration, in this case, we will be considering ma is equal to mg. We can consider this F is equal to ma as mg because we are moving something up. So gravity is involved in that, ma is equal to mg. Now the object gains energy due to the work done on it. We are applying some force, certain force on it. So work is done on the object. So work is done on the object means it has gained some energy. It obtained some energy. It possesses some energy. So this energy which is possessed due to its position, that is known as potential energy. So the work done on the body object against gravity is equal to force into displacement, that is equal to force is equal to mg, displacement is equal to h, that is equal to mgh. It's very simple, but yet you will have to do it. Okay, just practice it. Now you will have to find out the answer of this question. The kinetic energy of an object of mass m moving with velocity of 5 meter per second is 25 joule. Two things are given here. Velocity of the object is 5 meter per second and the energy associated with it, that is 25 joules. What will be its kinetic energy when the velocity is doubled? If we double the velocity, what kind of change will be there in the case of kinetic energy? What will be the kinetic energy if the velocity is tripled, that is 3 times, it is increased to 3 times. So double means we will have to multiply 2 by this velocity, isn't it? 5 meter will become 2 into 5 meter, and in the second case 5 meter, that is velocity will become 3 into 5 meter, 3 times velocity. So you will be doing this and finding out the value, and you can write the result in the comment box. Thank you for watching.